Okay. So, yeah, so I'm going to talk about, some things that we have been doing here recently about, using mostly AI agents. In particular, I think for this talk about how to how to do cosmology. So, this is kind of a very controversial topic. So feel free to really express your opinion at any time in the talk. I can tell you that, there are some people on favors about this, but there are many people against these kind of things. So yeah, let's see. All right. So let me see if I can go to the next slide. Okay. So the first thing is that we are organizing this conference next year in Spain. So the reason is because there will be an eclipse happening. So feel free to register. We will have also some support for students from Simon Foundation. So I think it will be an amazing event. We're planning for a big conference, maybe with 300 people. And if everything goes well, we will be on the beach and seeing this very nice eclipse. So if you just Google, like cosmology, Spain, eclipse, something like that, I think you will find it. And the summary of the talk, let me make this smaller, is that I will try to convince you that AI agents basically can serve as powerful research assistant. We can really use them to maybe think a little bit more broadly that maybe the standard way that we think. We can use them to code things that maybe are not trivial to code, and we can also create maybe like research draft very very fast. So I think it's really a way to explore the let's say the space of ideas much faster than if we humans do this. This is not really to substitute us, but really to help us. So I think this is really like the summary. And so let me briefly talk about what are these AI agents. So I think most of you maybe are familiar with large language models, things like ChatGPT. And let me just say that this is one of the most sophisticated technological developments that humanity has ever achieved. And they have been trained basically on a lot of data from the whole internet. So they are aware of many different things in many different fields, many different disciplines. And they, at least in terms of knowledge, I think they might be at a superficial level, they are better than humans. I don't think there is any human, maybe today, I might be wrong, but I think this is not the case. Someone who is able to be a semi-expert on mathematics, on material science, astrophysics, quantum physics, all these kind of disciplines. Whereas large language models know a little bit about these things, maybe not super in a super depth, but they know superficially these things. So the standard way that we use these large language models is that you make some query, you ask something to, let's say, ChatGPT or Gemini or anything, and you will get like an answer. So that's really like the standard way that we use large language models. And there are some things that are really, you know, um, there are some big limitations using in this way. So imagine that you ask ChatGPT what is the result of multiplying two numbers. Of course, if the numbers are like one and two or something simple, it's gonna give you the correct answer. And today is able to give you the correct answer even if the number is complicated. But this is because they use like agents. So the way that these models work is that they have been trained on this gigantic amount of text. And basically, if you're asking it, what is the square root of 3.7, blah, 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 unless it has seen exactly uh, this thing written in some document somewhere, it will not be able to give you like a correct answer. This model works basically as an S token prediction. And if they have never seen this kind of previous, let's say, question, then it will not be able to give you like an answer. So recently, people has realized that we can extend the capabilities of large language models by basically providing them with some additional tools. So, so for instance, imagine that the tool will still be to compute, like the square root of some arbitrary number. So what you can do is basically to write like a trivial Python function where you say, okay, so my Python function takes one number, and what I'm gonna return from this function is basically the square root of that number, right? This is really like a 2 lines Python script. And now we can basically use this tool when using large language models. So the way that this works is that imagine that your query will be like, what is the square root of this particular number? So the large language model will basically say, like, oh, this is asking me to compute the square root. But I don't, I have a tool that is able to carry out this calculation. So what I'm gonna do is basically invoke this function, basically this trivial Python function where I'm gonna take a number and I'm gonna compute the square root of it. So the question is like, what is this Python function, compute the square root, and basically return the result. Another LLM, what it's gonna do is gonna see that the query, the initial query is like, what is the square root of this number? And basically now it knows the answer because it has computed. So it's gonna be able to give you the correct answer. So this is an example of a very, very simple agent. This is called like ReAdd, that stands for Reason Plus Add. And you can imagine that now we can provide large language models with much more sophisticated tools, maybe tools that do coding, maybe tools that run simulations, maybe tools that, I don't know, they can maybe even point your telescope in a new region if, maybe this is what you plan to do, things like that. Oh, sorry, going down. So let me just mention this other very simple agent that is called RAG. So this stands for retrieval, augmentation, and generation. So the idea here is that imagine that you have some documents that are private. There will be always things that ChatGPT doesn't know. So, you can imagine that these are things like, I don't know, medical records, or maybe some Python library that you have developed last week, and it has not been trained on this. So the idea here is that you might be able to make a query about this particular data set. So, what happened with this patient, something like that. And of course, if you ask this question to ChatGPT, it will not be able to give you an answer because it doesn't know about this medical record. So the way that this works is that you can take all these medical records. This can be text, can be images, can be videos, can be in principle really anything. And then what they are gonna do is basically embed each of these documents using what is called an embedding model. And basically what you are doing is transforming a document, let's say a text document, into a numerical representation. You can imagine that this is just going to be a vector, let's say with 1,000 numbers. And these 1,000 numbers are meant to basically keep the semantic meaning of the content in this document. So the way that this works is that you have your query, what happened with this patient. What you do is like using this embedding model, you create a numerical representation of this thing, of this query. And then you also have a numerical representation of all your documents. And now what you do is basically like a similarity search. So basically you try to see, what are, given my numerical representation for my query, what are the things in these documents that are more similar to this? And at the end of the day, what really you do is a multiplication of two vectors. So you just compute like the cosine similarity. So it's basically the scalar product of two vectors. And then the piece, the document here that gives you the highest, let's say, cosine similarity is the document that you basically will pass into the large language model. And now what happens is that you have your query and you have your most relevant document. You can put this thing together, and now the LLM will basically have your query and will have all this relevant information, this particular document that is the most relevant one, and it's going to be able to give you like an answer. So this is, another very simple example of another agent that is basically able to retrieve information, maybe from some private documents, but you can imagine that this might be very, very good if we want, for instance, to look at the web. Maybe sometimes maybe you have an agent who is writing code for you and is using a particular library that recently has been updated. So now it's like, oh my God, so now what do I do? So you can imagine that you might have an agent basically reading the documentation for you and basically extracting the most important thing about, how do you really need to write this function to run this let's say this code. So this was all. I don't know if you guys have any question. Feel free to ask things, and as we get more, I think it's gonna become more polemic. Uh, yeah. So now let me maybe go back to cosmology. So what I'm showing here is one cosmological hydrodynamical simulation that we have run. This is part of CAMOS. So as you might know, CAMOS is this very, very large set of cosmological hydrodynamical simulations, state of the art, that we have run for many, many years. And the idea here is that we want to study cosmology on very, very small scales. We want to see if there is cosmological information on scales beyond linear or quasi-linear. And we know that if we go to very small scales, we will have to deal with baryonic feedback. So in this movie, for instance, you saw a lot of these explosions. These are either supernova feedback or agent feedback. And the problem about this is that the physics about all these things is very uncertain. So we don't really know how to model these things very well. So the idea of CAMOS was that we would like to run thousands of these simulations. But something that was very important is that we should not really rely on a single code. So for instance, what you can see here are 8 different simulations, all of them state of the art, Illustris TNG, Simba, Ramses, Eagle, Magneticum. So all these simulations have the same initial conditions. All of them have the same cosmology. The only difference is that they have been run with different codes. And as you can see, different codes make different assumptions. People model feedback differently in different codes. And what happens is that, when you look at all these things, these look like completely different. And the question is like, I mean, is there some of these are the ones that are more close to reality? So what I can tell you is that all the simulation roughly are able to reproduce reality. When you project these simulations in the observational plane, basically all of them are able to reproduce things like the stellar mass function or I don't know, properties about black holes, all these kind of all these kind of things that I think our galaxy formation colleagues care about. So CAMOS was designed to say that if you run simulations and you want to make theoretical predictions for how the universe look like on small scales, you need to take into account all these different range of possibilities into account. And if you develop a model to, let's say, extract information on small scales, this model should work in all these simulations. If it only works on Illustris TNG, it's great, but I don't think that this is something that maybe we can deploy with real data, because we know that the Illustris TNG universe is not really let's say, a copy of the real universe. So let me show you the last movie. So yeah, Camus was designed to basically train machine learning models. So it was very important that, we change the value of the cosmological parameters in every simulation. It was also very important that we vary the value of the astrophysical parameters in every simulation. So you can see here different simulations, and from one simulation to the other, you can see that maybe these bubbles that usually are like supernova feedback or agent feedback are very different from one to the other. And this is just a reflection that in some simulations, there are, how much energy you release with supernovae or AGMs can be very different. But also the other thing was that every simulation was run with a different random seed. So you can see that when you change from one simulation to the other one, the cosmic web like changes a lot. And this is just basically a reflection of how the initial conditions change. And this is important because when you train machine learning models, what you want is to basically marginalize over the initial conditions. If you train your machine learning models using always simulation with the same, let's say, initial conditions, then it's likely that your model will basically learn these initial conditions. Your model will make predictions assuming that the initial conditions are these and are always the same. And as we know, this is not the case because we don't know also the initial conditions of our universe. So to be more conservative, what you want to do is to marginalize over the initial conditions. That's why you run simulations varying the initial conditions, but you also want to marginalize over astrophysics because we also don't understand these things very well. And that's why you run simulations varying these parameters. So coming back to the large language models, and maybe why, for those of you that know me, is like, why Paco did you do these things? So at some point we were basically facing some problems. So I think as of today or last time I checked this, there were more than 100 papers that were written with Camus data. We have written some of them, but I don't even know these 100 what they are about. I got many emails from people. It's like, has someone done this? And it's like, I don't know, to be honest. And we have things where this problem is even worse, right? I mean, if you look at, I don't know, Euclid papers or maybe the ESI papers or any big collaboration, the number of papers is incredibly large. So at some point, it's very, very hard to keep track of who has done what and all these kind of things. Another thing that we face is that we have, because we have been developing this a very extensive documentation. This is something that I think we are very proud. But when you have a very nice, let's say, extensive documentation, that's very nice. But that also means that if someone wants to really use Camus, it might need to read a lot of things. And we all are busy, right? We all has things to do. And sometimes you maybe don't want to spend one day reading a lot of things that are, most of them are going to be relevant for your research. So, it might be very nice to maybe go exactly to the point. So, kind of in the same way that you ask ChatGPT how to do something like that, maybe you want to do something similar, but, maybe tailor for your particular project. And this is something that you can do also with your papers, if you are developing a software, anything like that. The other thing is that, Camels use a very standard data format, but still, there are many people who will face some kind of barrier. If you maybe are more like an observer or maybe you are working on a completely different thing, this might be the first time that you see this format. This might be the first time that you see all these things. So, it's going to take you some time to be able to really use these kind of things. And, another thing that now let's start maybe with the more polemic things. There are already like more than 100 papers with Camus, as I was saying, roughly 100. I can assure you that all these 100 papers, when they describe camels, is basically the same thing, because it's really what it is. I mean, there are so many ways to describe this data set. So, do we really want to even spend time writing this thing over and over and over again? This is, every time I write something about this, I spend maybe, I don't know, one day, maybe one afternoon, if I don't have meetings. And again, it's really to say exactly the same thing that has been written already before. So do we really want to keep doing this thing? Or maybe, this is some time that we can use for other things. So let me show you. And so we have developed this basically app. So if you go to, it's called Camels Agent. If you Google it, I'm sure you will find it. So let me come here and I'm gonna show you how these agents basically work. So this is gonna be a very simple, illustration of how these agents work. So you can come here. This is like the web. Everything is public available. You will just need to put your API key for Gemini. This is basically free, so you can just go. There are some instructions here on how to do it, and you have different agents for doing different things. So, for instance, one of them is gonna write like this camel section. The other one is basically allowing you to chat, let's say, with the documentation, so you can go directly to the point. There is another agent who is aware of all the CAMOS paper that has been written, so you can ask question to it, whether this has been done, what was done in this paper, things like that. We also have agents to look into let's say, the entire literature. And probably, a very impressive one is the one coding. I'm going to show you later how this works. So let me show you, for instance, you can just choose this one and you click here. Let me see if this is doing something. No. So select task. I'm gonna put this thing here. And basically what it's gonna do is basically taking, like the description that we have in camels and basically rewrite it. So the way that this is designed is, large language models is a next token prediction. So basically given some text is gonna produce a next word and there's the next word, the next word. But how much variability there is in this next token is something that is controlled by something that is called the temperature. So when the temperature is 0, you will basically get the same text over and over again. And then, you might be worried because, I mean, if you put this on the archive will say, okay, this has already been written. But if you set the temperature, let's say to 1, every time it's going to be different. And, some people say, okay, but this is maybe not ethical. She will really. So, feel free to express yourself. For me, really writing the same thing over and over and over again is maybe not the best usage of my time. But, okay. So let me show you the other one. So this is basically to talk with the documentation. So as I was saying, we have a very, kind of extensive documentation. And, sometimes there are people who, sometimes you only want to do a particular thing and you don't want to read all these pages. So let me, for instance, write something here is like, how can I download the data using Globus? So, instead of basically reading the whole documentation about where is this thing, oh, this failed for some reason. So let me see. Okay, so I don't have permission. Okay, not sure what is that. Let me try again. How can I download data using Globus? Okay. So it fails. I need to check this. But last time I checked, it was working. So sorry about that. Okay. Let me see if the other one works. Like, for instance, this one is to check the papers. So let's say cosmology with one galaxy. Let's see if this works. Okay. So something went wrong. These streamlits sometimes they change things, I believe, and some of the libraries are not compatible. So I believe this is what is going on. But okay, I'm gonna fix this, and if you want later, you can try yourself. I think the most important one was the coding one, and sorry that I will not be able to show you this. I think it's gonna fail as well. But in general, is that you can ask very particular questions about camels. You can say something like, okay, so can you write a code to compute the power spectrum of all galaxies in this particular simulation? And it's gonna do that. If you use like ChatGPT or Gemini or these large language models, you know that these are very, very good at writing code. And the only difference here is that it's kind of been like tailored towards camels. So it knows what is the structure of camels. It knows how to compute the power spectrum, given the data set and all these kind of things. So yeah, sorry, I'm gonna fix this. And yeah, apologies that I cannot show you. So let me go back here. And so what I was trying to show you, and not successfully, was that we have these very simple agents that are able to maybe write code. Some of them are able to check papers. Some of them might be able to look at the documentation, all these kind of things. So these are, again, relatively simple agents. I will say that the magic really happens when you start putting all these agents together. And this is what is called multi-agent systems. So, so agents can basically, they have different modes of interaction. So they can be in collaboration mode. So, maybe you have a few agents here that maybe the task is to prepare a meal. And maybe, you have one agent cutting the food, another one bringing the food, the other one cooking. It's just an illustration. In reality, you might have an agent coding, maybe another one checking the literature, and, maybe they might collaborate for that. But then, agents can also be in competition. And, there are cases where this is like desirable. Like I'm going to show you later, for instance, to generate ideas, you might want to, have an agent creating an idea and the other one criticizing it. And then, they might have, maybe some kind of conversation and the idea might be improved just from this interaction. So why this thing is very powerful in science? So, there are many usage of agents in science. Let me just, detail a little bit some of them here. They can do literature search and summarization. They can generate hypotheses. They can design experiments. They can do data analysis, but also interpretation. They are extremely good at writing code. They are very good, and this is where I think is a super good complement for humans, like cross-domain reasoning and integration. They can also, draft papers, and they are also very good at criticizing and refining, maybe documents. So let me very briefly just tell you a little bit about this project that we more recently created. It's called Denario. And this is basically a multinational collaboration. But more important than this is that this is like a super interdisciplinary, and you will see. So the main developers of Denario has been Boris, Pablo, and myself. Boris is a professor at Cambridge. Pablo is a machine learning researcher in Spain. And we have people from all kind of areas. So, Adrian is a postdoc here at CCA working in astrophysics. Pablo is a PhD student but is a quantum physics researcher, is now, I think, in Google. Camille is an assistant professor in chemistry. Chan, astrophysics in Austin. Raúl, astrophysics or mathematics physics. Yunyan is a graduate student at Princeton, astrophysics. Thomas is a philosopher. I always say the same thing. I never imagined working with a philosopher for a paper. But yeah, we have a philosopher, and we will probably discuss this later. Pablo is machine learning at Harvard. Shimanto is a student of Camille. Pedro is a student of Raúl. Chi Won is a researcher, a machine learning researcher in DeepMind. Li Song is a student at Cambridge, astrophysics. Qi Yao and Anupan are from biology. Urbano, he works in Harvard Medical School, so medicine. Wen Han and Bonnie are planetary physics. Pablo is, I think, at Cornell now, is biology. Antonio is mathematics at CISA. Janfei is here at CCA, astrophysics. Aidan, I asked him explicitly because, to be honest, I didn't really know exactly how to characterize what he does. So he told me that he does biomedical informatics. The first time that I heard about this. So Jay is astrophysicist working in gravitational waves. Almok and Josie are neuroscientists. Mateo, astrophysics. Miles, machine learning. Inigo, astrophysics. Osman and Shuwen are material science. Yayun is neuroscience. David Sperry is astrophysics, even though now is the president of the Simons Foundation. And then Chetania and Ukwal are basically coming from industry, are helping us. They are, I think, software engineers. That's, I think, a good way. So, we have basically created this kind of multi-agent system. It's called Denario, and it's public available. You can go to this website, and you can find everything there. So this is a system that is basically designed to help us, do research. So the idea here is that, you start with some description of some data. Imagine that you want to analyze some numerical simulations, or I don't know, you have maybe as Claudia, you have some data from CMB or, really anything. So this thing, is able to generate ideas, and then given the ideas is able to look into the archive to see if this has been done or not, is able to develop a research plan, is able to, carry out these research plans, basically writing code, making plots, creating a summary of the results, is able to write papers, and is also able to basically criticize these papers and give you like a kind of a referee report. So, we have different modules. So this is, for instance, the way that we create the ideas. As I was telling you, we have two different agents. So one of them is creating an idea. The other one is criticizing the idea. The analysis module, that is basically CMB agent, is a very, very sophisticated system that it was created by Boris Boliet and collaborators. And I'm not going to go into details, but what is being done here is that you have a very complex task, and given the complex tasks, you break down into smaller tasks. This is the planning phase. And then during the control phase, you basically write code for each of these things. And you can also create plots, and then you provide like a summary. And then, this is also able to, as I was saying, draft maybe papers or research notes, as you want to put it. And let me just maybe mention, with this thing, we have created papers in many different disciplines, and it has been reviewed by experts. So I'm not going to go into details because, the other day they told me, like, Paco, you look like so shallow. It's like you don't know anything about this, and it's true because, I'm not an expert on chemistry, so I'm not an expert on planetary science, mathematical physics, biophysics, biology. But let me maybe mention about this particular one. So this is a paper that really impressed me. a lot. So let me explain this because I'm able to describe this in detail. So the data that we have here are basically merger trees from M-body simulations, basically from camels. So yeah, I don't know if there was a question or something. Okay. So yeah, we have merger trees from many different simulations from camels, where every simulation has a different cosmology, every simulation has a different astrophysics, but also every simulation has a different random seed. So what you do is basically we just describe the data to the system. It's like, this is like the data that we have. This is basically, a merger tree where every node represent a dark matter halo, and every dark matter halo is characterized by things like the mass, the velocity, the concentration, things like that. And then we say it's like, for every tree, we also have a value of the cosmological parameters. There is a value of omega matter and sigma 8 attached to every tree. And then, just given this description, the system was able to, and we also tell it to basically write a paper using ideas from quantum physics. So in quantum physics, there is a thing that is called tensor trains. I don't know if you have heard about this. Maybe not. It was also the first time that I heard about this before Pablo told me about this. But the idea here is very simple. Is that people working in quantum physics, they have these quantum states where I don't know they describe these systems usually as a very bit matrix. And the problem of working with bit matrix, of course, is that they don't fit in memory. It's very hard to maybe compute the inverse of these things. It's really hard to manipulate these things. So the idea behind these tensor trains is that instead of having this gigantic matrix, what you will have is you can really represent this gigantic matrix as the multiplication of smaller matrices with some approximations in some cases. But that's really the core idea. And of course, once you have these smaller matrices, it's much easier to work with. So then what Denario did for this particular work was to say, okay, so I have a merger trees. So what I'm gonna do is to train what is called a graph neural network. So a graph neural network is, it's a kind of sophisticated, um, how to say, architecture coming from deep learning that is able to work with this irregular and sparse data. So basically, the idea was that we have these merger trees, and then the graph neural network was able to train on top of it, and it's giving you features about the tree itself. So, these features are kind of abstract, but you can imagine that this might be, how many, how many mergers you have at some point, or how does the mass of the main halo increases with time, things like that. And, because you are using deep learning, you can have like literally thousands of these features. So what this paper did was taking the merger trees, training graph neural networks on top of it, and then it was able to generate thousands of these features. Then basically arrange all these features have a matrix, like a bit matrix, and then it used these tensor trains to basically reduce the dimensionality. And after that, it was able to do some inference using like, these kind of random forest approaches. And it works. It works very well. And I can tell you that this is really something that really surprised me a lot. This is, in my opinion, a very, very sophisticated thing. Being able to train a graph neural network, being able to use these, let's say, quantum-inspired tensor trains from cosmological data. I think, um, I will say probably most of the undergraduates that I have worked with will not be able to do this, and many of the graduate students, it will take a lot of time for them maybe to do something like this. So, these are kind of examples of the things that it's able to do. Let me show you just another one. This is a paper. This is something that we're working on now with a student who is visiting us from Italy. So this is a student, Tommaso, who is an expert on cosmic voids. And when he came, he wanted to work with cosmic voids. And it's like, okay, so we can, go into things like the Quixote simulations. We can compute some summary statistics. We can, maybe do some simulation-based inference. Maybe after a few months or sometimes even a year, you might get an answer if this was really like a good statistics or not. So what I propose here is that, maybe we should, for this thing, we should do some kind of shallow, maybe exploration of this thing using Denario. And, what we thought is like, every time we look at voids, I think of this like some kind of, maybe like one of these Swiss cheese where you have these holes, things like that. So there should be other areas in science where people really study these holes or cavities. So in particular, one area that do this is like material science. So basically what we did for this thing was to describe the Quixote simulations, very carefully, blah, blah, blah. And then we asked the system to analyze the data using ideas from material science. And, it was able to write this paper. I don't think that we're going to win the Nobel Prize with this paper. None of this paper are going to win the Nobel Prize, believe me. But this is, as a research note, this really, in my opinion, very impressive. So what it did was basically taking halos from the simulations. It was able to do this thing that is called the maximal empty spheres, which is basically, you have your collection of points and you draw spheres in which there is no point inside it. This is actually equivalent to doing a Voronoi tessellation. And basically, yeah, now you have this collection of spheres that in this paper is kind of interpreted that these pores, this is just maybe just using language from material science. And then it was able to compute some statistics. So for instance, what is the mean radius of the distribution, the variance, the skewness, the kurtosis. So, nothing really fancy. But then, it was also able to compute a network of these holes. And I believe this is maybe things that people do in material science. So let me show you. Everything in this paper, by the way, is written by AI, everything. So let me show you. So for instance, this is an example of the spheres that it basically found from this halo density field. And, after it has the spheres, it was able to create this kind of networks, basically connecting these voids or pores, or whatever you want to call it. And then given this, let's say, network, it was also able to extract some information about these things. So these are standard things, I believe, from people working with these uh, from these kind of networks. So things like the mean degree, the average clustering coefficient, the largest connected component, and also this percolation metric that I think is also coming from material science. And at the end of the day, it did all these things. It was able to also do parameter inference. So this is the most relevant maybe panel. This is the constraint for omega matter. So this is like true. Sorry, this is true versus predicted. You can see that it is able to recover omega matter relatively well, taking into account that this is only 10,000 halos, but it fails for all the other parameters. And again, what do we do with these things? I think as a very shallow exploration of the data, now we humans, we might want to go deeper into this. And, I think it's really, really beautiful than that, maybe there are some things in material science that we are not aware of. And this may be a way to connect the two disciplines. And, maybe this is something that at the end of the day might also, I don't know, maybe yield better results than our standard maybe summary statistics. And, overall, as exploratory thing, I think is very, very powerful. So let me check, but I think this is probably all. Yeah, I think this is all I wanna say. So just, I think, trying to convince you that these AI agents are very, very useful tools. They can help us a lot. They can help us with coding, maybe making our ideas more broad. I think we as humans, we have priors, and sometimes very well the things that you have worked on for many years, but sometimes it's hard to go outside, your comfort zone. These kind of tools are very, very good for that. So yeah, I think with this, maybe I'm gonna stop, and if you have any question, please let me know.
Les, thanks, Paco. Is there any question? Yeah, please.
Paco, can I speak Spanish because maybe this discussion is...
Sin problema, lo que tú quieras.
No, a ver, lo primero que yo te preguntaría en realidad tiene que ver con esta falta de autocrítica que tienen los lenguajes, estos LLM, ¿no? Tal vez los que yo he usado son las versiones gratuitas y no funcionan muy bien, pero la experiencia que tengo es que lo que no saben lo inventan. Nunca te dicen, eso no lo sé, lo tengo que chequear. ¿Entendés? En tu charla entiendo que esta idea de los agentes un poco vendrían a hacer eso, a chequear, ¿cierto? Pero hasta qué punto uno, digamos, esa autocrítica que tenemos los humanos, al menos algunos, de preguntarnos si lo que se nos ocurrió es correcto o mantener esa duda y ir chequeándola a medida que vamos avanzando en el razonamiento y ver si vamos por el buen camino, no se lo veo a esos lenguajes. Entonces me pregunto si uno construye a partir de ahí, con esa falta de autocrítica, entre comillas, y construye algo mucho más complejo que está explorando ideas que a uno se le escapan, porque claro, no tiene un cerebro tan grande como lo tiene una computadora, hasta dónde no nos quedamos perdidos y perdemos la capacidad de saber si lo que está haciendo está bien o mal. Eso sería como mi pregunta, o sí, es eso, y quiero saber tu opinión al respecto.
Exacto, Claudia. No, esta es una pregunta súper buena. Por cierto, o sea, di la charla en inglés porque Matías me lo dijo. Le dije que si la quería en español, pero, pero
No, no, igual puedo hablar en inglés, pero me sale mejor en castellano criticar.
ah, no.
Me peleo mejor en castellano.
Ok. No, pero es una pregunta súper buena, Claudia. Yo por eso decía mucho que esto, en el fondo, es un asistente para nosotros, ¿no? No es como que esto nos va a reemplazar y tal. Em, o sea, por ejemplo, déjame enseñarte. ¿Dónde está este? Un segundo. O sea, muchas de las cosas que, por ejemplo, el paper es el que os enseñaba antes, pero por ejemplo, también tiene la capacidad de buscar en la literatura. Entonces, por ejemplo, por ejemplo, aquí dice, la idea es novel. Y lo que ha hecho ha sido buscar en principio, o sea, no digamos en todo el archive, pero ha hecho una búsqueda muy exhaustiva de quizá típicamente 50 papers. Y aquí te dice, por ejemplo, que ha encontrado este paper de Vimos, Public, bla, 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 que tiene algo que ver, pero que no es exactamente lo mismo. Y luego, o sea, básicamente es capaz de buscar todos estos papers y darte por lo menos una idea de si esto es nuevo o no. Al nivel de coding, en principio uno puede desarrollar agentes que pueden chequear si lo que está haciendo tiene sentido, si esto realmente es lo que se le pidió. Pero al fin y al cabo tienes toda la razón. O sea, uno en principio tiene que haber un humano realmente chequeando ahí y diciendo, ¿esto tiene algún sentido o esto realmente es muy fancy con estos dibujitos, pero esto en el fondo no tiene nada que ver? Entonces, yo creo que siempre tiene que haber un humano. Pero en otro sentido, Claudia, también te puedo decir que algunas veces a mis estudiantes los dejas 2 o 3 semanas solos y también empiezan a alucinar. Si te soy sincero, a veces van por caminos así un poco
Creo que
eh,
entiendo,
senderos oscuros, ¿no?
pero el tema es este, ¿no? A ver, ¿cómo lo puedo expresar? Uno va teniendo criterio por la
Ujú,
experiencia que le da haber pensado muchas veces y haberse enfrentado con cosas desconocidas y tratar de entenderlas. Si uno como científico, estudiante o avanzado, empieza a apoyarse en estas herramientas,
ujú,
la sensación que yo tengo es que vamos a ir perdiendo la capacidad de aprender cosas nuevas y de distinguir si lo que estamos viendo es vamos a, eso, ¿no? Vamos a perder la capacidad, no porque perdamos la capacidad, pero quiero decir, al no estar entrenándote vos como humano frente a lo que viene, ¿cómo vas a saber si lo que te están diciendo es simplemente verosímil o cierto? Porque hay una diferencia muy grande entre que parezca cierto y sea cierto, ¿no? O sea, eso es lo que a mí me genera un poco de duda.
exacto,
Bueno, no sé,
exacto.
o sea, igual me parece súper interesante esta idea de la capacidad que tiene esto que estás mostrando de decir, bueno, que conectar ideas que uno no se le va a ocurrir porque no estuvo expuesto a tantas fuentes de información. Pero tal vez yo lo tomaría como una idea, ¿no? Como que a reexplorar uno, ¿no? Como, mira, se me ocurrió esta idea, bueno, ¿para qué la pienso? Y empezar de cero a uno, porque si no es como que en algún punto vamos a perder la capacidad de hacerlo nosotros, ¿no? Y simplemente decir, bueno, si lo dice la IA debe ser así, pero yo ya no lo entiendo y no tengo la capacidad de hacerlo porque perdí el background, ¿viste? Que tenía, o sea, eso es.
Exacto, exacto. No, tienes toda la razón, Claudia. O sea, por ejemplo, para este particular estudiante, o sea, yo lo que le dije es, primero vamos a generar un montón de papers, vamos a leerlos todos. Si hay alguno interesante, por ejemplo, creo que este es interesante. Entonces, lo que vamos a hacer ahora es, este paper parece interesante, lo que tenemos que hacer es estudiar esto súper bien, entenderlo nosotros, por ejemplo, las ideas de Material Science, y luego, básicamente, rehacer todo por nosotros. O sea, realmente validar que todo esto está bien hecho y entenderlo. Y luego quizá escribir un paper. O sea, la idea no es tanto poner este paper simplemente ahí, en el archive, y ya está. Pero dicho eso, estoy seguro de que va a haber gente que haga eso. Porque
Sí.
como sabemos, el número de papers es importante para nuestras carreras. O sea, el sistema está hecho en una mala manera.
¿Y de qué manera se puede, digamos? Porque está bien, nosotros lo hacemos, pero y el que dice, bueno, chao, me escribo un paper, lo miro un poquito, lo modifico y va acá. ¿Y quién lo va a leer? ¿Un referee que o se lo pasa a la IA para que le diga si está bien o mal? ¿O lo lee y dice, bueno, yo no sé mucho de esto, pero bueno, me parece que está bien porque es verosímil, listo, pasa. Incluso la propia base de datos se ve contaminando de cosas que no son correctas. Entonces, no, por ahí estaría bueno, o sea, no sé si el filósofo estaba para la parte ética en el equipo, pero no solo por la ética, por ay, hay que hacer las cosas bien, sino hasta dónde esto tiene sentido. Quiero decir, la parte del referato, ¿no? Digamos, de que realmente sea, no sé cómo explicarte, pero hay algo ahí que como que va perdiendo sentido, publicar por publicar, que ya estamos en una situación donde esto, publish or perish, le está haciendo muy, como, ya pierde sentido. El avance científico de verdad está muy contaminado de cosas que no son avances científicos y están disfrazados de avances científicos. Entonces, de qué manera podemos usar la IA para reeducarnos en para qué estamos haciendo ciencia. O sea, por ahí eso también sería algo que se puede hacer con IA, no sé, ¿para qué estamos haciendo ciencia? ¿Qué sacamos de todo esto? Digamos, ¿qué aprendemos? ¿Cómo?
Exacto. O sea, hace poco hablamos con Licha Verde, o sea, ella es ¿cómo se dice esto? La editora en jefe o algo así de JCAP. Y ella lo que nos dice es, pues que eso, el sistema tal y como está diseñado ahora mismo, o sea, con herramientas como esta, se puede colapsar. O sea, no lo he hecho aquí, pero básicamente cada paper de esto tarda como una hora y lo puedo hacer en mi laptop. Entonces tú imagínate que yo, o sea, sin ningún problema yo podría producir 10.000 papers en una tarde. Si yo mandara todo esto a journals, o sea, por lo que nos explicó, cuando tú mandas un paper a un journal, hay un montón de trabajo ahí. O sea, hay como un editor que le echa un primer paso, si más o menos parece razonable, lo va a mandar a un referí. O sea, si hacemos esto brute force, el sistema se va a colapsar. podemos discutir si el sistema realmente tiene sentido o no. Quizá incluso, no sé, que se rompa y el hecho de que no tengamos que publicar tanto y tan malo, quizá no es una mala idea. Pero en el fondo, Claudia, o sea, esto digamos que es un uso malo de esto. Y por ejemplo, el ejemplo que siempre me ponían para esto es cuando la imprenta, por ejemplo, cuando la imprenta se creó, yo qué sé, en el siglo XV o cuando fuera, aparentemente hubo muchísima gente, o sea, hubo muchísima fricción en aquel entonces. O sea, la gente decía, o sea, hasta ahora eran los monjes los que escribían los libros y más o menos se controlaba que esto tuviera, ¿sabes? O sea, que estuviera de acuerdo con ciertas ideas y que la calidad fuera. Y parece que cuando se creó la imprenta hubo muchísima, pues eso, resistencia, porque era como que ahora cualquiera puede publicar, un montón de ideas malas se van a difuminar, todo este tipo de cosas. Yo creo que estas herramientas van a dar lugar a un montón de basura que va a ser muy fácil de identificar. Igual que tú desarrollas un agente para crear papers, es muy fácil diseñar un agente para filtrar estos low quality papers. Pero ideas que van a ser buenas, direcciones nuevas, ir más profundo, creo que para eso va a ser súper, súper útil. Entonces esa es mi cara buena para esto. Pero también van a haber cosas malas. Y estoy totalmente de acuerdo contigo.
Yo también estoy de acuerdo con lo último que dijiste, la verdad que es como en ese sentido, en el de asistente sí puede ser que te muestre algo que vos no habías pensado que sea muy novedoso, pero bueno, después la idea de quién es, de tuya o de la gente, ¿no? Es otra parte, es otra, es otra pregunta, pero bueno, gracias Paco, no sé si otros quieren preguntar.
Paco,
Gonzalo.
hola, ¿cómo estás? ¿Hay artículos ya en el archive creados por agentes o todavía no hemos llegado a eso?
Buena pregunta. Posiblemente los haya. Posiblemente los haya. No creo que haya mucha gente que tenga esta tecnología, pero déjame que te diga, Gonzalo, que, o sea, muchos de estos papers, porque algunos de estos papers realmente, o sea, creedme, son buenos. Este paper que discutía de quantum physics, a mí me encantaría mandarlo a un journal y ver si es aceptado, porque de verdad es bueno. Escribimos a Licha Verde y nos dijo imposible, o sea, esto está prohibido. Incluso el uso a veces de ChatGPT para reescribir, incluso eso está baneado. Entonces, ahora mismo nunca hemos puesto nada de esto, pero en Stanford han organizado este año una conferencia que es para AI Generated Papers. Es la primera conferencia que organizan sobre estos. Entonces, mandamos 3 papers. No sé qué sentido tiene organizar una conferencia y solo nos dejaban submitir 3. Podríamos haber mandado 300, pero bueno. Pero fuimos el número 221, 222 y 223. O sea, te puedes imaginar que otra gente tiene cosas parecidas. Entonces, no sé, hace poco hablaba también con un colaborador que decía, esta gente tienen un récord, digamos, publicando, digamos, gente un poco más senior. Y yo qué sé, durante los últimos 15 años han publicado, yo qué sé, 1 o 2 papers por año. Y recientemente tienen un montón de papers en Nature y están publicando cada 3 meses. Y es algo ahí está raro. Entonces, no quiero decir nada, pero es posible que la gente esté usando estas cosas. Lo que sí que creo es que sería bueno no mezclarlo con... O sea, creo que el archive debería de ser para cosas hechas totalmente por humanos. Creo que si empezamos a mezclar con estos AI papers las cosas de humanos, creo que no va a ser bueno. Podemos tener un archive quizás separado para estos papers y está bien. O sea, en principio, ¿no? Puedes tener millones de papers ahí, puede ser algo útil. Por ejemplo, este paper de Quantum Physics, quizá en el futuro puede ser útil para alguien haciendo algo. No es un paper malo, pero no deberíamos de mezclar.
Pero ¿cómo decidir? ¿Pero quién dice? O sea, porque eso es como, no, yo no me lo robé, no, yo no lo escribí con el ChatGPT, pero ¿cómo sabe que, ¿entendés? Es ética eso, es la... digamos, firmar no sé, a lo mejor es firmar una declaración jurada de esto fue escrito por mí y no por un agente. Sí, 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 hay
Exacto.
algo
Pero imagínate, Claudia, que esto, o sea, esto va a seguir mejorando, ¿no? O sea, ahora mismo, por lo menos, los papers que nosotros escribimos al nivel de las citas y todo eso, es un poco claro, que es un poco raro. O sea, las citas están bien, pero no son realmente las más adecuadas. Pero las cosas solo van a mejorar. Entonces, imagínate en unos años en donde realmente estas cosas pueden escribir papers que son realmente tan buenos o son indistinguibles con respecto a los nuestros. O sea, ¿qué hacemos en ese momento, no? O sea,
Pero
o sea,
cuál es el plan de Elisha Verde para no desbordarse en Jacob? ¿Eso lo discutieron?
no tienen, por lo que yo entiendo, no hay plan. Es simplemente el sistema se puede romper pronto, pero no hay plan, hasta donde yo sé. Ninguno de estos papers nos ha dejado submitirlos. Ninguno.
bueno, pero el peligro para mí está en después se lo mandas al otro agente que te diga, dale la forma que parezca un paper escrito por un humano, ponele, y quién se va a dar cuenta. Eso es lo que digo. Ahí está la ética, porque si yo entro a un supermercado y no me robo un paquete de galletitas, porque tengo cierta ética, supuestamente tengo que hacer lo mismo con un paper, pero ¿hasta dónde está? Si no te ven y nadie se entera y el paper está bueno y vos necesitas paper para publicar y te parece y lo leíste y trabajaste y te parece que tiene razón y revisás las citas y las cambiás para hacerlas más creíbles o más ciertas o más adecuadas y entonces el paper ya tiene una contribución tuya, listo, ya está, lo mando. Pero eso no es,
Ujú,
pero ¿hasta dónde está? ¿Quién dice lo que es ético y no? Es una discusión muy, muy compleja
ujú.
que creo que es el momento de darla a gran escala. Pero bueno, como todo lo que tiene que ver con la ética y la moral es difícil, porque cada uno tiene su moral también. Entonces,
Exacto. Pero quizá, o sea, todo esto también, Claudia, es porque el número de papers es importante para nosotros. O sea, no sé cómo será en Chile, pero, o sea,
en todo el mundo, eso es un desafío.
exacto, exacto.
Eso para
Pues
mí.
es importante.
No,
Y
no,
con estas cosas creo que lo que va a pasar es que el número de papers va a ser completamente irrelevante, ¿no? Ahora puedes tener un undergraduate con 100.000 papers y entonces quizá vamos a valorar más la calidad, igual que los libros, ¿no? O sea, hay libros súper malos y hay libros súper buenos. Mm, para mí no importa que un autor haya escrito un montón de libros y sea muy, no sé, muy eficiente con esto. Lo que me importa es que el libro sea bueno cuando leo un libro. Quizá con esto va a ser realmente lo mismo.
sí, pero digo, tal vez es trabajar en que, no sé cómo decirlo, en que sea obvio, en que empiezas a emerger lo bueno, porque es lo que pasa con Internet. Nosotros somos de cierta edad donde cuando empezamos a estudiar no había Internet. Cuando empezó a haber Internet, fue un recurso increíble porque podías encontrar la información y fue súper rápido y lo usamos un montón. Los chicos que nacen ahora, los niños que entran en la universidad, no pueden encontrar lo que es bueno en Internet. Es tanto lo que el acceso es tan overwhelming que no pueden encontrar lo que necesitan. Entonces esto parece como que va en esa dirección, ¿no? Los papers, antes se publicaban los buenos, entonces vos sabías buscar, ¿no? Algunos eran mejores, otros eran peores, pero todo era válido y correcto. Hoy, si va a haber tanto un mar, un océano, donde no se va a distinguir lo que es bueno ¿no? De lo generado por IA, que muchas cosas son buenas, pero otras van a ser basura. Ojo, que hay paper generados por humanos que también son basura, pero quiero decir, es tanto que y lo importante no emerge. Entonces, me parece que no solo en ciencia, no es solo lo que estás mostrando vos, en general en Internet, en la información que hay en Internet, está pasando esto. Es un océano de cosas donde lo importante no emerge. Y bueno, y no veo que haya una discusión en ese sentido como como sociedades, ¿no? Como humanos de tratar de empezar a discernir un poquito lo que sirve y lo que no, ¿no? Para que no sea
Pero no
útil.
estoy seguro, Claudia. O sea, yo ya soy lo suficientemente viejo que me acuerdo cuando yo estaba estudiando. O sea, mis profesores, los más seniors, siempre decían, o sea, cuando el archive empezó, decía, antiguamente la gente solamente mandaba los papers a los journals y se publicaban, ¿no? Y ahí realmente tenías un, digamos, un filtro para decir, ok, esto realmente es bueno o esto no es. Cuando el archive empezó y era como público, era como que esto va a ser un desastre, ahora cualquier persona va a poder mandar cualquier tontería, ahí todo el mundo lo va a ver, cómo vamos a distinguir los papers buenos de los malos. Y al final no fue tal cual, ¿no? O sea, realmente hay un montón. O sea, si miras en el archive hay un montón de, yo diría, de...
Están publicados, pues les crees, porque todavía está ese método, ese sistema de los referees que son humanos. No, no porque sean humanos o ya, quiero decir, pero de alguien que seriamente lo está mirando. Pero si yo veo un paper en Archive que no está publicado y no conozco a los autores porque han publicado otras cosas y no sé qué, y dice una idea muy rara, yo creo que es basura que se filtró en el Archive, ¿entendés? Porque como
Pero
si
claro, hay un montón de papers que se publican que son bien malos. O sea, yo tengo experiencia en todo, ¿no? Papers súper malos que se han publicado y otros papers muy buenos que tuvimos que estar con el referee. O sea, eso, no sé yo, ¿eh?
bueno, es complejo, es complejo. No sé si hay alguien en el chat preguntando aquí.
A ver, creo que
No creo que era...
Belén dijo.
Ahí,
Sí, la
que
puedes.
este, déjame ver si entiendo, Belén, lo que dice. Sería muy descabellado que esté agregado como autor, que esté agregado como autor el agente. Sí, yo creo que sí. O sea, si, si el agente ha hecho casi todo en el paper, estaría como menos bien decirlo. Pero seguro que va a haber gente que no lo diga. Siempre que... También os puedo decir otro ejemplo de un estudiante que estaba acabando un paper ahora que estaba muy bien, o sea, un método muy sofisticado. Y al final era como que salía una conclusión muy espectacular, pero no entendíamos lo que pasaba. Entonces era que, bueno, simplemente vamos a publicar esto y ponemos que this will be future, this will be addressed in the future, right? I'm pretty sure that hemos hecho quizá todos esto. Entonces simplemente se lo pasé a los agentes estos y después de quizá 20 o 30 papers encontraron realmente la solución. La solución era algo trivial, la verdad. O sea, era... y hacía el paper mucho menos interesante. Entonces al final ahora estamos discutiendo, es como que debemos incorporar esto, y yo digo que sí, y otros, pero es que no, esto va a hacer el paper ahora mucho menos interesante. O sea, lo que quiero decir es que los humanos también tenemos un montón de,
sí,
de
sí.
bias, de...
¿Más preguntas? ¿No? Bueno, si no hay más,
No, no, no.
gracias.
Gracias, Paco.
Bueno, si no hay más preguntas, agradezcámosle de nuevo a Paco.
Gracias.
Gracias, Paco.
Gracias,
Nos
Paco.
vemos. Si pasáis por Nueva York, avisarme. Aquí estaremos. Gracias.
Gracias.
Ah.
Chao, gracias.
Chao.